Hank, would it be possible for you to demo a lab on DevNet and show us, what it can do and, how it helps?
Absolutely. So I actually let me go through. So we'll actually start from here so we can see where we're going through. So the lab that I'm going to use is, let's see if is a lab focused on iOS XE programmability. So topics that you can do against iOS platforms. And so these typically are things like NetConf, RESTConf, Yang, all of these areas that are there. And so I clicked on it here, and so we've actually got two variations of this lab. One is a reservable lab, and that's what I'm seeing here. And so anybody, and again, completely free, can come in here, click the reserve button, and you'll be in just a few minutes, you'll get an email with the login credentials for your own little sandbox lab, which will have a CSR 1000V, has a development workstation with development tools preloaded on it so that you can experiment with it. But we also have a variation of this that's called our always on lab. And our always-on labs are just like they sound. They're always available. They're available directly over the internet without any kind of VPN. The credentials are posted, and you can use those to test an API call. And we use a lot of our always-on labs for our learning labs that go through. And so that's what I'm going to use here for this demo is the always-on variation of this. And so what I'm going to go through here is going to work without any kind of VPN or connection, and you can just take advantage of these. So let me switch over. And so I'm going to start in Postman. And so Postman, if you're not familiar with it, it's a free software, though there's a optional subscription you can pay for additional features, but most folks can get by with the free version of Postman. And it lets you send REST API calls to any type of an endpoint. And what's nice about Postman is you can save them as like bookmarks. Postman calls those collections of example API calls so that you can go through. And so what I'm going to work through is, I'll make the screen just a touch bigger so it's easier to see. So I'm going to be talking to one of our sandboxes, and this is our always-on sandbox. And so this URL here, ios-xe-management.cisco.com on port 9443, and right there is the username and password. These are all published right in our Sandbox Catalog, is the device that I'm going to communicate with. And this is an iOS device that supports RESTCONF. And RESTCONF is a REST API protocol for the network, and it's a standard protocol from the IETF. I like to say that it's kind of the natural evolution of SNMP and MIBs is where you get NetConf and Yang from. And so here against this device, I'm going to start out by just getting a list of all of the interfaces that are there. And so up in Postman, I clicked on my bookmark or my collection item, and we can see here's the API call, and it's just HTTPS to the IP address and port. These little double curly brace things are variables that are pulling out of that environment that I saw. And then we're going to target RESTConf data, and then we're going to look for the IETF list of interfaces. And if I send this off, I get back right here in Postman a JSON body that represents all of the interfaces that are currently on this device in our sandbox. And so, as I mentioned, this is our always-on sandbox, and this Gigabit Ethernet 1 is the management interface, which is why I put the description, don't touch me on it. And in general, our users are pretty good about not touching that interface. But all the rest of these are available for folks to go through. And so you can see examples where this interface was configured by NetConf and someone had pushed some config at it. Gigabit Ethernet 3, it had somebody from routertricks.com, it looks like, was doing some work off of this sandbox that's there. And then you'll see all of these loopbacks that say configured by RESTConf, because this sandbox is actually used as part of the RESTConf learning lab that it's available on DevNet. So if you take my RESTConf lab that I wrote, you'll actually create some of these types of configs that are there. And so what's nice about this is this data comes back in what's called JSON format. JSON is a standard data format that is very easy to work with inside of a programming language. When you get data back in JSON, you can very easily say, well, give me the name of this interface. Give me the IP address of this interface. The reason that this type of data format is so important in automation and programmability is if I had to parse through the clear text output, if I were to just send a show IP interface to a device, not every platform has the same basic layout of how that text goes through. When you do a software update, you might have a change and a variation. Does the subnet mask come back as a /24? Does it come back as the 255.255.255.0? And those variations can run havoc on your automation routines, which is why the push to APIs that provide data in this structured format is so important, because it's much, much easier to absorb this. And I can show you an example of that. And so I'm going to switch over to a code snippet here. And so the part that I want to focus in on is right here at the bottom. And I'll even make it a little bit bigger so that we can see it. So what I want to focus in on is this part right here at the bottom. And in a future video, we can dive into more of the code and kind of how all these pieces go through. But the key element I want to look at is right here, how I'm able to get things like the MAC address from this device. It's a very easy representation. This is the part that's important in the code. And if you're new to Python, you can just focus where I'm highlighting here. I can get the MAC address of this device simply by saying, okay, off of the information from this device, give me the physical address. And that's what the IETF calls the MAC address. I can get the packet information very easily by saying, from the statistics, give me the in unicast packets. And that's the value of that structured data. If I want the name, I can simply ask for the text of the name. Very simple to go through. Now, if we compare that to how you would do this from a CLI perspective. So I'm going to switch over here. And so now I'm looking at what's another Python code, but rather than using a structured data format like RESTCONF or NETCONF, which is what we were seeing in the last example, now I sent a CLI command off. I sent, where is it up here? I sent a typical show running config interfaces command, which is what you've probably sent at a CLI before. And then what I have to do is actually use Python regular expressions to parse this clear text that came back through. And so I sent this off to, I think, an iOS device. And so, okay, I could get the interface name by looking for a line in the response that started with the word interface, had a space, and then had some piece of information. I could get the description by doing the same thing. And then I could get the IP address and mask by looking for a line that said IP address, and then it had two pieces of data separated by a space. Now, that may not seem that hard, but keep in mind, this will only work on an iOS device that happens to use this exact format. If I were to try to send this and parse that information from a different device that maybe used slash notation instead of masking for an IP address, this wouldn't work. Whereas by going to that structured data, now I can just focus in on the information that I'm after. And that's this key part we have to go through. Many of us start in automation in Python by doing things like this, which is just shoving some CLI through Python onto our devices. And that's a great place to start. But I would say make sure that you very quickly start to take that next step and learn about some of these other capabilities that are there. Because in the long run, that's what it's going to take to do these things kind of for real in a production environment. Now that clearly begs the question, we have to make sure that the software platforms and the hardware platforms we use support these interfaces. And that's a discussion that's definitely worth having as well and can be challenging because not all of us have the equipment platform or the software versions with these interfaces. So my general advice to folks is whenever possible, use those interfaces, the newer interfaces that are available, and only resort to the CLI when you must.
So what you're saying is like a REST API or a NetConf API. Some devices will support that, but a lot of traditional iOS devices don't. So then you're kind of stuck with CLI scraping type of thing like you're showing here. But try and use NetConf REST APIs when you can. Is that right?
Exactly. That should be the goal. And as I've worked with more and more enterprises doing this type of stuff in real environments, that's becoming important. And so the discussion, I always start out with when I sit down with a customer the first time and are trying to help them on their journey to network automation, I always am faced with, well, we've got gear that's 10 years old and we have to automate today. I'm like, that's great. We can do that. And so we walk through examples like this where we're doing CLI examples. Ansible actually under the hood for the most of what you're doing with Ansible is actually shoving out CLI commands. We've got options for those cases. But by and large, and the soonest I've had it happen is actually 4 weeks after a first meeting with a customer. I was back and they mentioned, this is so difficult. The automation is so valuable, but the CLI makes it such a challenge and is adding in so many headaches that they've actually started down this path to accelerate their refresh because they've seen what's possible if they can go through, and the value that their organization can get by adopting automation quicker is worth the cost of actually upgrading software and hardware across their platforms.
That's interesting.
Because the long benefit is there. And that happens so often. We're not seeing anybody upgrade their switches today because they just happen to want a Catalyst 9000. We're seeing people upgrade their networks because they need these new features. And a very common new feature is this programmability element. If I can go through and say, you know what, if you try to automate against your existing footprint of Kier, I would say you need to give yourself 6 months just to get started and prove out and test all of your pieces because of the challenges you'll have. But if you have these new platforms that are using these standard interfaces, well, you can cut your rollout time for that down in a half or into a third because it's much more consistent and the code becomes simpler and there's less debugging and troubleshooting necessary. And it really is, it never works on the first meeting because people don't believe you. They have to have some pain, right? They have to have fought with.
You're not a good salesman, Hank. You're not a good salesman.
Yeah, honestly, that's one of the reasons I moved to DevNet is because I'm not a good salesman. I would much rather help people kind of go through their problems and then try to push stuff at them. And so I'm more than happy to go talk to somebody the first time and say, okay, let's enable you, go through. And then let them see some of these problems themselves. Because I know in the long run, they'll get there themselves. And it's always easier when you learn a lesson yourself than if someone tells you. And I've got a young son, and I see that all the time. So.
Agreed. Sorry, I interrupted you. You carry on. So you were demonstrating this code. So.
Oh, okay. Yeah, so we've got these pieces of code. So what we'll do is I'll switch back and we'll look at this example here. So this is an example. This one happens to use NetConf because it just was the Python code that I had available. And so this is going to connect out to a device. It's actually that same iOS device and retrieve some information that's there. And so if we run this code sample, make this full screen. So I'm going to go ahead and run that code sample, Python example 2. And so this will connect out to the device and very quickly give me the ability to print out all of the information about this interface. So I can see it's gigabit Ethernet 2.
So just help me understand this. Sorry, Hank, to interrupt you. This code is running where and where are we connecting to a live device? Is that right?
So I ran this code on my laptop, which is just a Mac running Python. And the device that we're connecting to is actually that same always-on sandbox that we were looking at. So I can prove it to you to an extent. So here's gigabit Ethernet 2, and we can see the description is configured by NetConf. If I switch back to Postman and we actually look at gigabit Ethernet 2 off of that command that we sent off to the live sandbox, we can see there it is there. Gigabit Ethernet 2 configured by NetConf.
Okay, so you're running that code on your laptop at your house, and you connecting over the internet to this always-on DevNet Sandbox. It's an iOS V router type thing. Is that right? Like a virtual router?
Yep.
And then
we'll go to what we're all more.
Sorry, go on.
Yep, I can go to what we're all more comfortable with, which is I'll go log into it with SSH so that we can see it. And so here I'm just
Yeah, for most of us, if we don't see the CLI, we won't believe
no,
you.
I'm with you. So I'm going to go ahead and log into this guy. I got to go grab the password because I don't remember. And here's a case where we want everybody to know these credentials because these sandboxes are available for everybody to use. And so I just logged in with SSH to iosxemanagement.cisco.com. Now SSH on this one happens to run on port 8181 because we had to NAT it through a firewall. And so I'm on a CSR 1000V. And so if I look at show run interface, gigabit Ethernet 2, we can see this is that device that I just sent. So I ran the CLI command, and so here's what the CLI command comes back and shows. And then the Python command, I was able to run and grab that data. But the data came back with NetConf in this structured fashion. So I didn't have to parse through all of this information in the text and regular expressions or string matching. I could just say, hey, give me the interface or give me the description, because they come back in that ability to grab it in that JSON style format.
And what I noticed, sorry to interrupt again, is this doesn't show you the MAC address. So if you want to get the MAC address, you have to like show interface and the interface, don't you? Whereas in your code, I'm seeing the IP address and the MAC address.
Correct, because what I'm using in the code is I'm targeting. Let me figure out which window I was in. Not that one. There it is. And so here, let's just make sure it's the same. So here's the MAC address that my code said. It ends in AC30. And if I switch, we should see the same thing. So it ends in AC30. So same device that's there. Now, the way that the NetConf command that I'm using here is it's targeting an IETF data model. It's a Yang data model that represents an interface. Okay. Now, those data models are available on GitHub or, that you can look at. And so if I go over, I'm actually going to look at it. So ls-l. And so this file here, IETF interfaces Yang, is a Yang data model that the IETF puts out and says this is a standard way to describe an interface. Cisco, as well as most networking vendors, support these data models so that we can go through. And I can look at that and say, Yang. So I'm going to display this data model in a format that's just easier to consume than looking at the raw Yang language, which can be a bit of a bear. So I'm going to look at this data model using this tool called pyang, which is Python Yang, and it just lets you process and display data models in a more easy to read format. Yep. And so I look at this. And so what we were targeting here is this section of the data model called interfaces state that I can dive into. And so this was what we were reading out. And we can see this model has nothing to do with the CLI or the show command output. This model is actually looking in at the underlying nature of how the device works and returning this information. So it won't always match an exact CLI command. But inside of here, if I look at this and I target interfaces state, I can see that each interface will have a name, it'll have a type, it'll have an admin status, and it'll have a fizz address. That's the MAC address that comes through. It'll have statistics, and then I can go through and get the counters and things that are off of it. And so this is the information that was requested by my Python code, which let me read that out. So if we keep this in mind, where I can see, again, interface by the name, I can see statistics, all of those details are there. If I go back and I look at the actual Python code that represented this, we can see right here, I was looking at the name and then the text attribute, and there's some intricacies on how the Yang model works because the name happens to be the key of how we uniquely identify an interface, which is why that little text piece is there. Yep. But here's how we could get the statistics. Statistics, and then in unicast packets, I was able to pull that out of that same Yang model by just targeting those very specific attributes. And in Yang, we call those attributes leafs, which is all sorts of confusing for network engineers used to spine leaf architectures. Yep. The leaf inside of NetConf is a bit different. It just means an attribute. And so we've got a fizz address attribute that I could grab very easily.
Hank, can you go back to that output of the data model?
Yep.
That's kind of like a MIB, is it?
Yes. So when we talk about, when I teach people about NetConf, Yang, and RESTCONF, I always do it in relation to SNMP and MIBs because the corollary is there. And most of us are familiar with MIBs and SNMP. And so the MIB is this structured model of information that we can request using SNMP. But they've got all of these really difficult to remember OIDs that we have to dive into to figure out what's there. With SNMP, we get information about MIBs. NetConf and RESTConf and Yang work the same way. Yang is like this new standard MIB. It's a way to define information about your devices, about your network that you're interested in. And in this case, we're looking at a standard model for an interface. Now that model, the way you get that information is you have to go over some sort of a transport protocol. You have to connect to a device. And that's where NetConf and RESTConf come in. With NetConf and RESTConf, you can connect to a device and ask it to send you information. And that information you'll ask for is going to be is related to a Yang model. And there are hundreds of Yang models that represent different elements of a device. If you're interested in the routing status, if you're interested in the physical attributes of the device, how many cards are in it, is the power supply working? Like there are models that represent all of that information as well.
That's great. Sorry, I feel like I keep interrupting you, but if you want to just flow, that's fine. Otherwise, I'll ask you stuff.
Nope, nope, it's good. Does that make sense on the MIB, SNMP, NetConf, Yang correlation?
Yeah, so like, so just correct me if I'm wrong. So a Yang model is kind of like a MIB. So you'd have a MIB for like an interface and a Yang model for an interface. And then in SNMP, you would have SNMP that would talk to the device. So an SNMP server would query a device and based on the MIB would return some information. And here you're doing something similar, but you're using RESTCONF, was it, to connect to the device and pull back the information from the Yang model. Is that correct?
Yes, that's correct. Now, in the demos that I went through, I've used both NetConf and RESTCONF on the piece. But what's nice about those is I can target the same models, the same Yang models, no matter which protocol I want to use. And I like to demonstrate both because they each have value and some people are more comfortable with one or the other, as well as the fact that RESTCONF is a brand new protocol and not as many devices support it as support NetConf. And so it is important, at least right now, for network engineers to be comfortable with both. Even if you prefer RESTCONF, you do need to become comfortable with NetConf because RESTCONF support is still building across the portfolio from Cisco as well as other vendors.
So I missed that. So when you did the CLI Python script, was that NetConf?
That was actually NetConf because I happen to have that Python script ready. But it's targeting the same device and the same information as what we did in Postman using RESTCONF. Okay,
yeah, so that makes sense. So in Postman, you were using RESTCONF. But in Python, you're using NetConf. So as a network engineer, I should, if I want to get into this, just to step back a bit, again, you said that the problem with CLI scraping, in other words, where you send like show runs or show start or show interface, is that it differs from device to device, and that when a device gets upgraded, that could change, and that would break your script. So you want to move to an API or application programming interface type model. And the languages to learn, or the protocols to learn, should I say, would be NetConf and RESTCONF. Is that kind of right?
That is spot on, David. And what's nice about learning NetConf and RESTCONF and the associated models is there's also this push in the industry to have consistent models across platforms and vendors. And so this model we're looking at here, the IETF model, came from the IETF, and it's supported on Cisco iOS, NXOS, as well as XR. And I haven't looked for sure, but I'd probably bet a significant amount of money that it's also supported on Arista and Juniper and Brocade and all of the devices that are taking these because it's an IETF standard. There's also OpenConfig, which it's not a, I hesitate to use the word standard because OpenConfig isn't like the IETF. What OpenConfig is it's a large group of very large organizations, folks like Verizon and AT&T and Google and Cisco and Juniper and these other ones. And they're coming together to build models that are standard across those. And so you'll find OpenConfig support across multiple vendors and platforms as well on that side. So if I write code using, for example, this IETF interfaces model, I could target that same code to any of the Cisco platforms as well as other vendor platforms. And because the data coming back is all based on the same Yang model, my code will work no matter what platform I'm on. That would never be the same if you were doing getting this information through the CLI.
Yeah. So, Hank, can you go back to the main DevNet page and kind of tell us, because we're going to have to wrap up soon, I suppose, is if I, as a network engineer, want to get started now, so I'm right in the beginning, which labs, which courses would you suggest? Is there like, I wouldn't say a learning path, but kind of like which next steps could I take? What are your recommendations that I should do? So like after this call, I want to do something now. What would you recommend I do?
That's a fantastic question. So we'll go through those. And we can actually, in the description and the information about the call, we can send some links to some of these.
That'd be great.
And so underneath the learning tracks here, if I jump back over to the learning tracks, I would say, let me find the one that I'm interested in. I wish it would be at the top. So there's a couple of places we can go through. And so I've scrolled down here, and we can see I've got this Introduction to DevNet. This is a great set of labs that'll introduce you to DevNet, some of the resources that are there. And then we've also got this network programmability for network engineers module that I would highly recommend folks take a look at. And so if I look at this track, you'll find that there's a lot of good content in here that will kind of walk you through some of these fundamentals. And this first module that's in here is actually focusing in on model-driven programmability. And that's what we're talking about when we talk about NetConf, Yang, and RESTCONF. It's model-driven programmability. And so we've got labs that will walk you through the fundamentals of that. We've got the introduction to ACI programmability, NXOS programmability, Meraki. Lots of good examples that are in here so that you can dive into some of these topics to go through. In addition to this one is we've got content on, let me find it real quick. There we go. So the other one that I think would be useful is if you're very new to programming and you haven't done a lot of coding yet, we've put together this Intro to Coding Fundamentals that will walk you through some of the basics of coding and APIs, Python fundamentals and basics, and it's a very quick piece. You can see it's only it should only take you a couple of hours. Yeah. This does not replace kind of a full-on Python course. What the intention of this module is just to kind of give you enough exposure so that you can feel comfortable reading and executing scripts in other labs. And so you can go through this if you've never seen any Python or you've never done anything else. This is a great place to at least kind of get a bit of familiarity into some of these topics, some of the basics of how to write a script, where variables work, how loops go through. And then from that, I always recommend folks go take like a full-on course through one of the many available channels that are on that. But this will get you started on some of those pieces. So I think those are good learning labs to take. And then if you want to sit back and kind of listen to more, the video course that I mentioned, the Network Programmability Basics video course, is another great resource that folks can take and go through. And once again, I'll just continue to say it, all of these resources are completely free. There's no cost to take advantage of any of these pieces.
Yeah, I mean, I think we should highlight this. I mean, this like Intro to Coding Fundamentals or some of the other labs, you're actually using Cisco gear. So it's not just like like some other Python courses which are just based on servers or something else. These are, you actually get to interact with Cisco equipment in these labs. Is that right? Yeah,
so it is. So the coding fundamentals, this is one of those ones where, as I mentioned earlier, we were talking about learning Python on how to do it, and sometimes there's benefits in not necessarily getting so weighed down in the networking pieces initially. Yes. We considered that when we wrote these. So you'll see a little bit of networking in here, but you'll also see a lot of examples that are just kind of generic examples going through in that. But when you go into the introduction to model-driven programmability, which happens to be the next module that's listed here, all of these will be using Python or the API skills against Cisco infrastructure that's all hosted in our labs. And so these labs actually use that same always-on sandbox that our other demos and examples have used today.
So with the always on, that means you don't have to reserve a lab, you just access it. But there are some labs which you have to reserve where you get more devices, something like that. Is that right?
It is. Let me find the full Sandbox Catalog.
Hank, I'm punting you guys here, but it's a great resource, man.
Oh, no, please do. I mean, we love the pieces that are there. And so what I've opened up here is the full Sandbox Catalog. And so you'll see our sandbox is organized by categories. And so you can dive into different colors that are there. But you'll notice some of these say reserve and some of them say always on. A reservable sandbox, when you reserve it, that's yours. It'll be a dedicated sandbox just for you. You'll get a VPN credentials to connect into it, admin credentials to everything, and it's yours for the length of your reservation. Always-on sandboxes are they're not necessarily simulators, but they are shared sandboxes that are always on. And we'll try the DNA Center one. That one should be up. So these are all the labs. We'll see some of them say reservable, some of them say always on. And so I'm going to scroll down to one of our new ones, which is our DNA Center always on sandbox. And so if I click on this lab, what we'll see is it'll actually show me a topology diagram of what this sandbox looks like. And so I'll zoom it out a little bit so we can see we've got a DNA center. It's got the public internet because that's how we get into it. But there's an ASR, there's several Catalyst switches, and then there's a couple of hosts providing traffic on this sandbox. And then over on the side, I can see all of the connectivity information. So it gives me a URL and then credentials, DevNet user Cisco 123 exclamation point. And so if I go ahead and I open this up, and outside of the fact that DNA Center doesn't like Safari, we can go ahead and log in. And again, I got those credentials right from the Sandbox page. I don't want to save them. And this will let me log directly in. And so this URL, sandboxdnac.cisco.com, is available anywhere. David, if you wanted to, you could log into it as well right now. And it'll give you access to a real DNA center that's available out there.
Wow.
This DNA Center is actually running the early field trial code of what DNA Center platform, which is the API capabilities baked into DNA Center for integration for northbound APIs. And so you can come into the Sandbox and you can take a look at all of the capabilities that are there. So for the APIs, as an example, underneath Developer Toolkit, we've got APIs. And this will show you the different APIs that are available for DNA Center, and you can run these. So underneath Know Your Network, I can get a list of the device. I can see how to get the devices that are available. So all the API calls that are there. And so these are the types of capabilities. And so we've got sandboxes for DNA Center. We've got them for ACI. We've got them for iOS and NXOS. And if you are also studying voice and you want a complete call manager system, or sorry, communications manager system or contact center, we've got sandboxes for those as well. And the only difference between the always on and the reservable are those always on ones are shared. And so sometimes the credentials you get may not be full admin credentials. And we always tell people, remember, these are shared environments, so kind of respect other folks that may be using them at the same time.
That's brilliant. Hank, unfortunately, it looks like we've run out of time. So I just wanted to say thanks very much for, spending some time with me and sharing all this knowledge. And I just want to make the point so that everyone knows this. Hank's mentioned many, many terms in this call, and that's just the beginning. Hank's fortunately been kind enough to say that he'll join me for many calls. So if you have questions, please send tweets to Hank and to me on Twitter, or make comments below this video. Let us know what you want to learn. And Hank, again, thanks so much for your time and for demonstrating all this stuff. So thanks.
Absolutely. Thanks for having me. And I look forward to our next one where we can dive deeper into a topic, and hopefully we'll get some feedback from the audience on kind of what they'd like to hear next. So
that's great. Thanks so much. Cheers.